Capillarity. Capillary action is an interesting effect of surface tension, where this capillary effect refers to the rise on the left hand side or the falls of a liquid either in a small diameter tube or within the small space between two pieces of smooth plates. Due to the capillary effect, as shown here in figure A, the liquid in a container curves out slightly at the edges where it touches the container surface. In this case, the force of the liquid's adhesion to the molecule on the surface of its container is greater than the force of cohesion between its own molecule. So this liquid is called the wetting liquid. The meniscus of surface of a wetting liquid will be concave. See? So for this wetting liquid, okay, the adhesion force is greater than the cohesion force. One good example of a wetting liquid is water. Now the opposite for a wetting liquid is shown here in figure B. So this is the non-wetting liquid. Okay. So the non-wetting liquid curves down at the edges. So for this non-wetting liquid, the force of the liquid's adhesion to the molecules on the surface of its container is smaller than the force of cohesion between the liquid's own molecules. So here, the adhesion is smaller than the cohesion. So for this type of a non-wetting liquid, the meniscus of will form a convex surface like this. And one good example of a non-wetting liquid is mercury. Now, as shown in these two figures, the meniscus make a contact angle with the side of the container. So here, you can see here the contact angle for the wetting liquid is here, and the contact angle for the non-wetting liquid is this. So this contact angle defines the direction of the surface tension of the liquid. It can be used to measure the ability of a liquid to wet the surface of a solid. So for example, the contact angle is less than 90 degrees. See here on the left hand side for a wetting liquid, but it is greater than 90 degrees for a non-wetting liquid here. The strength of the capillary effect or the surface tension force is controlled by this contact angle. Okay, so in this case, the equation for surface tension force, F sub st, is equals to sigma times cos theta times L, where this F sub st here is the surface tension force, sigma is the surface tension of the liquid, and this theta is the contact angle, while the L here is the length over which the surface tension acts. So in summary, capillary action is an effect of surface tension, where this capillary effect refers to the rise or fall of a liquid, either in a small diameter tube or within the small space between two pieces of smooth plates. For wetting liquid, here the wetting liquid, the adhesion force between the liquid and the container molecules is greater than the force of cohesion between the liquid's own molecule. So the adhesion is greater than the cohesion for a wetting liquid. The opposite happens for the non-wetting liquid, where the adhesion force between the liquid and the container's molecules is smaller than the force of the cohesion between the liquid's own molecules. So here the adhesion is smaller than the cohesion for the non-wetting liquid. The equation for surface tension force, FST, okay, is equals to sigma times cos theta times L. In the next video, we will look at how to derive the equation that we can use to find the capillary height here.